Okay, circular motion is exactly how it sounds. It's motion in a circular path. So I've drawn a blue object here, little blue ball, and it is traveling in a circular path represented by the black circle. And the thing to note about circular motion is that the velocity is always tangent to the circle. Okay, so this green vector here is our velocity vector. Okay, and the velocity is always going to be tangent to the circle. So no matter where the object is in its path, if it was here, the velocity vector would be this way. If it was over here, the velocity vector would be this way. So the velocity is always tangent to the circle. And it's also moving at a constant speed. Okay, we're talking about uniform circular motion, uniform meaning constant speed. So the speed is not changing. It's always going to be traveling at the same speed around the circle, but there's a constant change of direction. And since velocity is both speed and direction, it's a vector, if the direction is changing, the velocity is changing. Okay, so even though it's a constant speed, we have a changing velocity. In other words, we have an acceleration. Okay, so this is another type of accelerated motion. The difference here is that this is called a centripetal acceleration. We denote it AC to distinguish it between linear acceleration, which is change in speed, an object speeding up or slowing down. Here it's the direction that's always changing. And centripetal acceleration is v squared over r. You can go look in the textbook. They give you an explanation of how we derive this. I think it's easier for now just to know that centripetal acceleration is v squared divided by r, where r is the radius of the circle. Okay. And that centripetal acceleration is always towards the center of the circle. So here's our acceleration towards the center of the circle. So no matter, again, where you are in the circular path, that acceleration always points towards the center of the circle. Okay, if I was up here, it would still point in this direction. Okay. And that acceleration, like I said, AC, centripetal acceleration, v squared over r. Now, the thing to remember also about a circular motion is its periodic motion, like wave motion that you studied in Physics 11. So in periodic motion, that's motion that has a period that it repeats. So the time that it takes for this object to travel around the circle is known as the period. And period is still measured in seconds, but we give it an uppercase t for the symbol, okay, rather than a lowercase t, to denote that it's a different type of time, that it's a periodic motion. Okay, so the time for one complete circle is known as the period. The period is also related to something else called the frequency, and that's 1 over the period, which equals frequency, lowercase f. And frequency is measured in units called hertz, where 1 hertz is 1 cycle or 1 circle per second. Okay. So period measured in seconds, frequency measured in 1 over seconds, which is also known as a hertz, H-E-R-T-Z, hertz. So the frequency is how many circles per second, where the period is the time for 1 circle. The other thing that's unique about circular motion is because we know that speed equals distance over time, and we now know that the time is the period, the distance that this object travels is just the circumference of the circle. So 2 pi times the radius, 2 pi r divided by the period. That's the speed. So now that we know how to define the speed of this object, we can plug that back into our equation for the centripetal acceleration and get v squared over r. So v squared, so 2 squared is 4 pi squared r squared over t squared. So that's my v squared divided by r. So one of the r's cancels, and what I have for centripetal acceleration is 4 pi squared r over t squared. So I have two different ways of calculating centripetal acceleration. This method here, if I know the speed of the object, and this equation down here, if I know the period. Okay. And now that I know acceleration, I can put that into Newton's equation and find something called the centripetal force. Okay, so the force that's acting towards the center of the circle, the force that's keeping the ball moving towards the center of the circle. So this could be mv squared over r, or it could be 4 pi squared r over t squared times the mass. So again, two different ways of calculating that centripetal force. Okay, and this is the force, again, that is keeping the ball moving towards the center. Without a force towards the center, the object will travel along this path, velocity. Right? Newton's first law, an object in motion will want to stay in motion. It will want to keep going in this path. The only reason it doesn't keep going straight is that there is some force pushing it towards the center of the circle. Okay. And that force can vary. We're going to talk about in the next couple of videos two different types of circular motion: horizontal circular motion and vertical circular motion. Horizontal circular motion is just like it sounds. Motion where the circle is horizontal, flat on the surface. So a good example would be these cars traveling around a traffic circle. So the force has to be towards the center of the circle. That's the centripetal force. Okay? If there's no force pushing this car towards the center of the circle, it would keep going in a straight line around this track. But it's the force of friction between the tires of the car and the road that keep pulling it towards the center. Okay, again, you can imagine if it was the middle of winter and the road was very icy, so the amount of friction available was less, this car might slide if it was traveling too fast. And the difference between horizontal circular motion and vertical circular motion is that for horizontal circular motion, we don't have to worry about the force of gravity acting downwards. Okay? It's not in the direction of the acceleration. So that force does not affect the acceleration here. For vertical circular motion, the force of gravity is towards the center of the circle. So depending on where you are in the circular path, the force of gravity has a different effect on you. Okay, at the top of the circle, it's acting towards the center of the circle, so in the direction of the acceleration. At the bottom of the circle, it's acting away from the direction of acceleration. Okay, so this will have a different effect. And we'll talk about that in the next couple of videos.